Have you ever stood at the foot of a giant mountain, looked up at its towering peak, and wondered, how on earth did this get here? Well, you're not alone. It seems like mountains have been around forever, silent witnesses to history. But the truth is, they're constantly changing, growing, and wearing down, all thanks to the incredible power of our planet. So today, let us embark on a journey deep into the Earth's crust to uncover the secrets of how mountains are made. First, let's get a basic idea. The Earth's surface, or crust, isn't one solid piece. It's broken up into huge slabs called tectonic plates. Imagine a cracked eggshell, and you've got the picture. These plates are always moving, floating on the semi-molten layer of rock beneath them. They drift apart, slide past each other, and sometimes they crash head. And it's these epic collisions that create the most spectacular mountain ranges on Earth. This process is called orogeny, which is just a fancy word for mountain building. When two continental plates like the one carrying India and the one carrying Asia, the rock has nowhere to go but up. The immense pressure causes the Earth's crust to buckle, fold, and get pushed. This is how the Himalayas, the mightiest mountain range in the world, were born. And believe it or not, they're still growing by about a few millimeters every year as the Indian plate continues to push into the Eurasian plate. We call these fold mountains because the rock layers are literally folded like a piece of paper being squeezed from both ends. The Alps in Europe and the Rockies in North America are also fantastic examples of fold mountains. But what happens when an oceanic plate collides with a continental plate? This creates a different kind of mountain. Since the oceanic plate is denser, it gets forced underneath the continental plate in a process called subduction. As the oceanic plate sinks deeper into the Earth, it melts, creating magma. This hot molten rock is less dense than the surrounding rock, so it rises to the surface. When it erupts, it forms volcanoes. Over millions of years, repeated eruptions can build up massive volcanic mountains. The Andes in South America are a perfect example of a volcanic mountain range formed by subduction. They are part of the famous Ring of Fire around the Pacific Ocean, a hotbed of volcanic and seismic activity. There's another way we get mountains, and it doesn't always involve a direct collision. Sometimes, the Earth's crust can be stretched or pulled apart. This tension can cause huge blocks of rock to break and shift. Imagine a block of wood that cracks, and one piece drops down while the other stays up. The piece that is pushed upwards is called a horst, and the piece that drops down is a... This creates what we call fault block mountains. The Sierra Nevada range in California is a classic example. It's essentially a giant tilted block of rock that was uplifted along a fault line, creating its steep eastern slope. Finally, we have dome mountains. These form when a large blob of magma from deep within the Earth pushes its way up into the crust but doesn't actually erupt. This underground pressure forces the overlying rock layers to bulge upwards into a dome shape. Over time, the outer layers of rock can erode away, exposing the harder, igneous rock underneath. The Black Hills of South Dakota are a great example of dome mountains. So, from the dramatic collisions that create the Himalayas, to the fiery eruptions that build the Andes, and the massive blocks of Earth being pushed skyward, mountain formation is a powerful and ongoing process. It's a slow-motion drama that has been playing out for billions of years, shaping the beautiful and diverse landscapes of our planet. The next time you see a mountain, you'll know the incredible story of its birth. Thanks for watching. If you found this journey into geology fascinating, don't forget to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next adventure. See you next time.